So we're going to walk through a couple of server implementations to illustrate how this stuff works. We're going to focus here on the different strategies. I'm not sure if we'll walk through all of them, but we'll walk through a couple of them. And so you can get this at the EX2 project in my WebMVC folder in my Live Lessons GitHub repository. So here we are in the EX2 folder, and we're just going to focus here on the implementations. I think you get a good sense of how the controller and the strategy and the application and stuff work at this point. So let's go ahead and take a look at a couple of the implementations just to have fun with this. So we're going to start off with the one that does sequential streams. So one of the methods here is going to take a list of quote IDs, and it's going to go ahead and turn that list into a stream, and it's going to go ahead and look up in basically an in-memory array or list, and it's going to get each quote by its ID because they're ordered by the ID, and it's going to return that back into a list. No muss, no fuss, very simple. Here's one that will just do a simple search where it's going to go ahead and go through the stream sequentially, looking for everything that contains the query. Any BerraQuote that contains the query turns it into a stream, no problem. Here's the same one where we take a list of queries, and we go ahead and we'll convert the list of queries into a stream, and then we use the any match technique. This should look very familiar because this is what you basically did for assignment 1A. So that's the way we do things sequentially. Pretty straightforward once you get the hang of it. Let's take a look at the parallel version of this, and this will take us no time at all because the parallel version is exactly the same as the sequential version, the only difference being that we use parallel stream instead of sequential stream. And so you can see that everywhere we had sequential stream, we had stream, we now say parallel stream. So the nice thing about streams is once you get it working for sequential, it's often trivial to make it work for parallel. And you'll notice for the version here that does the search, we take a list of queries, and then we take those queries and we run those queries in parallel. So for each request, we're going to run each request in parallel, and we're going to search the queries in parallel. So it's two levels of parallel. The next version I'm going to show you is the one that does parallel streams with a twist, and this is a really fun twist. So what we're going to do is we're going to take the list of search queries, and we're going to convert the list of search queries into a single regular expression pattern that will basically be query 1 or query 2 or query 3 or query 4 up to query n. So we're going to turn the list into a single regular expression. So that's what we're doing here. We're turning the queries into a string. We're lower casing it. We're replacing the way that a list works is it encodes the string with these square brackets to separate each element in the string. And we replace the square bracket with the regular expression beginning, and we replace the comma with the or bar, and then we replace the closed square bracket with another regular expression feature. And then what we're going to do, this is really cool, check this out. For each BerraQuote, we're going to go ahead and see if that quote matches any of the regular expressions. So unlike the previous implementation where we, in parallel, searched all of those things, this time we're going to use a regular expression match to search the regular expression queries. So pretty darn cool, and just a fun way to show off how to use regular expressions. And then the last implementation here is also really fun. This is the version that uses structured concurrency. And this is a bit like your programming assignment, but to make things interesting, I have tweaked it somewhat. And so what we're doing here is we're going to use batches. So the way your current solution works is for each movie, that will become something that will be searched in parallel. What we're going to do here is rather than do it on each BerraQuote, we're going to do it on each batch of BerraQuotes. So let's say that there's 100 BerraQuotes, and let's say every 10 or so, those things will be searched together. So each search will be sequential for 10, but they'll be in parallel for each chunk of 10. So the way we do this is we have a batch size, we have a constructor that can override the batch size. And then what we're going to do is we're going to have structured concurrency here. This approach doesn't really do anything fancy. It doesn't do batches. It just takes the quote IDs and searches them in parallel. That's not any different from what we've done before. Here's where things get interesting. So if we're going to search a query, what we do is we make ourselves a structured task scope, and then we call the getBatches method, which will take the list of quotes and return a stream of, it'll return a stream of batches. So this splits the list into a sublist and returns the sublist as a stream. So if we take a look at getBatches, what getBatches does, it's a really cool little generic algorithm here. It takes a list and a batch size, and it makes an iterator that will traverse the list going through this thing in batch size chunks. So we start at 0, and then while we haven't reached the end of the list, we're going to increment the iterator by batch size each time. So this is going to iterate. It's going to create values of those numbers. And then we're going to come in here, and we're going to create a sublist, which will be from I, starting at 0, with the min of I plus batch size or list size. That's because the very final version of the list will probably not be an even batch size. So that's going to create a sublist, and then we use map to obj to turn this into a stream of sublists. So that's a nice little generic program to take a list and turn it into a stream of sublists of size or batch size elements. And then what we do is for each of those batches, we're going to call the findMatchTask method, passing in the batch to work on and the regular expression query that we're passing in here. And we make the regular expression query by making a regular expression. And making the regular expression basically uses that same technique we saw with the parallel streams, regular expression approach, where we're going to convert the queries into a single regular expression. So we get these regular expressions, and then we call the findMatch. And each of these things will be forked off to run in a virtual thread to work on that many batch elements using regular expressions. And you can see what this does is it just takes the batch, the quotes, the batch of quotes, probably call it batch quotes, and then goes ahead, turns that batch quotes into a stream, and then filters out stuff that it only keeps things that match the actual query. So kind of a fun little example. And this, of course, runs in a structured task scope. So all those things will run in parallel. And when we're done, we join, and we throw an exception if things went wrong. And then we gather the results together into the final result. And of course, this is going to come in as a list of futures to lists of quotes. And so we're going to flatten that list of futures of list of quotes into a stream of lists of quotes. And then we're going to flat map those things together to be a stream of lists of quotes, which will eliminate anything that was empty where there weren't any matches. And then we're going to turn that into a list. So this should look somewhat reminiscent of your parts of your programming assignment. I've tweaked it ever so much so it's not as identical by using batching and using regular expressions and so on. But if you want to get a feeling for the overall flow, I recommend you take a look at this particular example.